So now let's discuss this problem, right? I will read it. A shaft carries four masses A, B, C and D of magnitude 200 kilogram, 300 kilogram, 400 and 200 respectively, right? Okay. And revolving at radii 80 mm, 70 mm, 60 mm, 80 mm in the planes, right? So now you have to consider the planes also, right? Measured A at this much, measured from A, right? Means like the distance to the planes for the following masses, right? Measured from the first plane, right? Measured from the first plane A, right? To the next one is 300 and the one next to that is 400, the one next to that, the last one is 700 mm, right? The angles between the cranks measured anti-clockwise. Be very careful, generally angles are measured on the anti-clockwise direction, right? Like the first mass we keep it horizontal, right? A to B is 45, then be very careful how the order is given, right? A to B, then B to C, then C to D, like that. But we will see this in clearly when we are going to focus that angular position diagram, right? Then our target is the balancing masses are to be placed. That means like they give that the balancing masses are to be placed in planes X and Y, right? Okay. The distance between planes A to X is this much and between X to Y is this much, 400 mm, right? And between Y to D is this much. Oh, that is also given, right? Okay, no problem. If the balancing masses revolve, okay, the masses that we are going to add in order for the balancing are at a radius of right, that means the radius of the balancing mass, right, the crank radius, right, that is 100 mm, right? So they are simply asking us to find the magnitudes and the angular positions, right? Okay, fine. So now let's carefully focus. Now what is our mx here? Balancing mass that we keep at the plane X. What is my? The balancing mass that we keep at plane Y, right? Okay, so now we'll go for the most important type of the diagram, right? Now this is the most important diagram, right? So this diagram, the angular position diagram. See people, this is very very important, because now see, this is the first mass 200 kilogram. Now we consider this as horizontal, right? This is mass A. Then the angle from, see, the angle from A to B is 45, right? Then see, B to C is 70. See, that is how it is sketched, right? Again go for the problem, right? B to C is 70, then C to D is given. So what is C to D? C to D is 120, right? Is it? C to D is 120, right? And that's it, right? I want to check C to D again. Yeah, it is correct. C to D is 120, correct, right? So now this diagram is very much important, right? The angular position diagram, right? That gives what is the respected angle between each and every mass, and the radius is also given, right? Like radius for certain masses are given, right? And the value of these masses are also known, right? Again go for the problem, right? Now just focus, what is this X? This is the mass that you are going to attach at plane X, but but still we don't know what is the exact position, right? Still we do not know what is the exact position, right? But okay, let's wait, right? And there is another mass that we are going to attach at the plane Y, right? Okay, doesn't matter, we will see how to do that, right? So just focus the angular position diagram, right? Okay, that is clear. Now this is the next thing. Now this diagram clearly explains the structure of the planes, right? This diagram will clearly give an idea about the structure, the distance to the plane X measured from A, and distance to the plane B, see, distance to the plane B measured from A, 300, distance to the plane C measured from A, and distance to the plane Y measured from A, and like distance to the plane D measured from Y, right? So this plane diagram is always be very careful, right? When you are going to move to the right side, right? So when you are going to move to the right side from the reference plane, we consider it as positive. And when you are going to move backwards, that means when you are going to move towards the left side from the reference plane, so we call that direction as the negative, right? So this diagram is also very important, right? Okay, so now the next thing, now we are going to focus on the tabular method, that means the table, right? Now you clearly need to have an idea about how you should sketch or how you should obtain this table, right? Okay, now The first set is for the planes, like like plane for the mass A, and the other one is for the plane X, B, C, Y, and D. Now this side is for the planes, right, and this side is for the masses, right? So what is the mass at plane A? 200. Mass at what is the mass for the plane B? Like that. And the mx and ml, I mean the mass that we have attached at the plane X and mass that we have attached at the plane Y, that is not known. Okay. And how about the radius? That means how about the crank radius for those masses, right? All those crank radius values are also given, right? And see, again, go for the problem. Now in the problem it is clearly said the crank radius for mx and my is 100 millimeters. So 100 millimeters means in meters it is point. Now be very careful about the units also, right? That is also very much important, right? So that diagram is this table is very important. Now we know that here we are going to consider something called the centrifugal force. You know that, right? So that centrifugal force is the thing that actually causes the imbalance, right? But here there is a scenario that omega is the same value. So then we know the centrifugal force is given by m omega squared r. So all these values we divide by omega squared. So finally that imbalance force we define by mr. See, mr. Imbalance force we define by mr. So this, right? So that is how we define the imbalance force. The multiplication of m and r, right? The multiple of m and r, right? So once m is known, here what is m? Be very careful. Here m is meters, right? That is what I thought. Here m is meters, here kilogram is the unit. Right? Be very careful. Here mass, see, that is the problem. Be very careful about the units, right? Here this simple m denotes the mass, unit kilogram. Simple r denotes radius and unit meters, right? Okay. So here you have to get the multiple, because we are going to consider the multiple of mass and the radius, mass and the crank radius, okay? So then 200 into 0.08 is 16. Mx into the crank radius is this much. So like that, now you know how you can obtain this table, right? And then when considering the dynamic balance, right? Dynamic balance, that is the balancing of couples, right? We have to balance the couples also, right? Due to the masses that are kept at several planes, right? So for that you need to find the distance to the respected plane from the reference plane. Now we consider the plane of x as the plane x as the reference plane, right? So the distance from the reference plane to itself is 0, right? So like that, this side, carefully look at this one, right? By looking at this line, by looking at this diagram, you have to consider this set. Just consider one value, or just consider for y, distance to the plane y from the reference plane. Here it is mentioned 0.4 meters, 400 meters. Okay. X to y. See, x to y. What is x to y? 400 millimeter. That means here it must be 0.4. Now carefully check that. Now the last one. What is the last one? Last one is the moment value. So how we get the moment? Actually, it is the distance to the respected plane from the centrifugal force, right? But the centrifugal force we have already obtained with the multiple of mass and the crank radius, right? So that you have to multiply by the distance to the respected plane from the reference plane, right? So then you can obtain this. I mean this into that, like 21 into 0.2. So like that. By multiplying this with that, you can obtain this side, right? I hope that is clear, right? Okay, right. So now the next part, right? So now the next most important thing is to sketch the couple polygon and the force polygon, right? Now this is the most logical thing in this problem, right? Okay, fine. So let's start. So now here, just carefully focus. Now if you are going to consider the centrifugal force side, there are two unknowns, right? So definitely it is not possible for us to sketch the force polygon because there are two unknowns. Focus the couple polygon. In the couple polygon, there is only one unknown thing, right? Because now we know that as a polygon, it must get closed, right? If the system is balanced. Okay, so now we are going to solve this problem in such a way that the system has attained both the static equilibrium and as well as the dynamic equilibrium, right? Okay, so now just focus the values that you have obtained for the couple side, right? So here in couple side there is only one unknown, right? And we know that as the system is now dynamically balanced, right, the couple polygon must get closed, right? So definitely then we don't have to worry about this one unknown, because we know that the polygon must get closed, right? Okay, now let's start sketching. Now what is our reference side? That means like which side we are going to keep as horizontal. Now see, this is the first side. Okay, let's start from this one. This is the couple side. Okay, right. So now wait, now just focus the couple polygon. Okay, so what is the first couple that we are going to sketch? First couple will be minus 1.6. Now here there is a scenario related with the direction, right? So now just I will tell you that. Now just consider this angular position diagram, right? So now this is the mass and this is the crank radius. Now here we are going to consider the centrifugal force. Now centrifugal force is the force that acts away from the center, not towards the center. Force that acts away from the center. That means the direction of the centrifugal force is away from the center, right? But now when you're going to consider the like force polygon, it is sketched in such a way. Now see, it is going away from the center. See, the mass is here. Now we consider that as horizontal, right? So with respect to that, we measure angles of the other masses, right? But now when you are going to consider for mass A, see, it is sketched in such a way that it is going away from the center. So in the force polygon, it is sketched in that way, right? Just to show you that, right? But we have to start sketching from the couple polygon, right? Because that is the first polygon that we are going to sketch. Now if this minus guy is there, now this minus is because now the plane that belongs to A is at the left side of the reference plane, so that is why it is negative, right? This is the reference. Now it is at the left side of the reference plane that belongs to A, right? Left side, right? So minus 1.6, right? So select a suitable scale. Now scaling is not a magical thing to you, right? Just select a suitable scale. Now sketch minus 1.6, right? So now this line is actually parallel to this crank radius, right? Got it? So sketch minus 1.6 over here, right? Then this is 0, don't have to worry. Then focus next one, the couple generated due to the mass that is attached to the plane B. Now see, what is that? What is the value of that couple? See, that is 4.2, right? What is the position of the mass B? Now it is here, right? So now see that, just focus this 4.2, right? See, that is that 4.2. Now see this line, right? Now see, it is a positive 4.2. Focus, it is a positive 4.2, right? Positive means definitely it is going towards the direction of the mass, away from the center. Now see, this is the center, this is the mass, so it is going towards the mass, right? Centrifugal. See, now this 4.2, just focus this 4.2, right? Now carefully focus, this 4.2 is actually parallel to this crank, right? Because here we have mass B. Now this 4.2 is exactly parallel to this crank, right? So that is also okay. Now this left turn, then from here to here 4.2, it is okay, right? That is why it is very important to sketch this according to the scale, right? The next one is what, 7.2, right? The couple, because of the mass that is kept at plane C. What is that value? 7.2. Now what is the position of C? C, it is going like that, right? That way. So now where we have stopped for the last time? See, for the last time we have stopped at there. We have stopped at here, right? So now that 7.2, see, just focus the 7.2, you are going to sketch from here. Now this line, this 7.2, now when sketching this 7.2, you can consider any scale, right? That means such that 1 unit of this couple is indicated by, let's say, 2 millimeters, like that, right? So that you can select according to you, right? So now this 7.2, see, now this 7.2 value is actually parallel to this crank, right? Okay. So what is the angle? I will tell you that also. This minus 1.6 angle, you don't have to worry, because like, you know, this is along the x-axis, right? And for the mass B, it is making an angle 45 with the x-axis. See now, when you are going to consider this 4.2, this line making an angle of 45 with the x-axis, right? So now when you are going to consider this line is making an angle of what? That must make an angle of 115 degrees. See, because the reason here to here 45 and okay, because the reason here to here it is 45, and here to here it is 70, right? B to C it is 70, here to here 45. So 70 plus 45 is how much? 115, right? So now starting from this position, it is making an angle of 115, right? Okay, I hope you got it. See now if you're going to consider this line 7.2, right, it is at an angle of 115 degrees measured from the x-axis, right? 115, right? Okay, agree, right? So now we have sketched this one, and that one, right? Okay, now next thing is the couple generated because of the mass that is kept at the plane D. See, the plane D is here. See, plane D is here, right? So the next couple is actually the couple that is generated because of the mass that is kept at the plane D. Now see, what is that value? 9.6. What is the angle? What is the angle? Now again look at this angular portion diagram, right? 45, 70, and then for see 45, 70, then from here to here, what is the angle? That is 120, right? Here to 100, so 120 is here to here, 120, 70, how much? 190, right? So 190, 45, how much? 235, right? Check it again, huh? From here to here 120, 170, 190, right? So 190, 200, then 235. So this angle, the angle, right, up to this mass, right, measured from the reference x-axis, right? See, measured from the reference x-axis, right? Now this is the x-axis, right? See, this is the x-axis. So angle from here to here is 235, right? Now see, now this 9.6, right? See, this 9.6 is sketched in such a way that it is parallel with this crank, right? See, it is parallel with this crank, right? And if you're going to measure the angle, you can see with reference to the x-axis, right? The x-axis at the first quadrant, right? X-axis that belongs to the first quadrant, it is making an angle of 235 degrees. See, it is 9.6. Now the couple polygon is done. That's it, right? Because there is nothing else for you to sketch. But one guy is there, that guy is actually the 0.04 times mi. You don't know how to sketch that because you don't know any value, but you know that as this system is balanced, right? As this system is balanced, this couple polygon must entirely get closed, right? So it's very easy. Then starting from here, because still you don't know what is the direction even, then starting from here, without any doubt, starting from here, complete this polygon, right, by connecting this point D to the starting point where you used to sketch the vector O A dash, right? But generally see A dash, actually that includes the position of the couple, right? Actually now here when sketching this minus 1.6, you have considered a certain center point, right? That's how to say, that's not a center, that is the origin, right? So anyhow, as the system is dynamically balanced, right, then you can connect this point D dash, right? What is the stopping point? What is the last that is the last point that we have reached while sketching this 9.6. Now you can connect this point D dash to the origin, because why? The polygon must entirely get closed, right? Done, right? So now we have obtained the couple polygon, right? So now see now it is completed, right? So now definitely now the other thing, you actually don't know what is the angular position, right? You exactly don't know what is the angular position of the mass that is kept at the plane Y. Do you know that? Seriously, you don't know. You only know the crank radius only, right? But from the couple polygon, now you can get to know that now in all these previous cases, just focus, now in all these previous cases, right, this couple vector is entirely parallel with the crank. Again, I am telling this couple vector is entirely parallel with the crank, right? So now here, as you have completed it, right, as you have completed the couple due to the mass that is kept at the plane D, now definitely this couple vector is actually parallel to the crank radius that belongs to the mass that is kept at the plane D, right? Now see, then construct a parallel line to this, Again I'm telling, construct a parallel line to this that passes through the center, right? See, like that. See, now see this line, can you see this line? See this line, can you see this one, this dotted line? Now see this dotted line, this dotted line is actually parallel to this line, right? Okay, right, so now we know from the couple polygon, right? So now we have, after sketching this C dash D dash, right, we have completed the rest of the line, right, in order to complete the couple polygon, right, by extending this point D dash up to the starting point, right? Because now what is the reason? Because the reason is now this couple polygon must get closed, right, because the system is dynamically balanced, right? Okay, so now we have just completed this line, and the couple polygon is closed now, right? So now just measure this length, right? And actually what is the unit of for the couple? Kg meter squared, right? So now you can measure this length, then multiply that length from the scale factor, right? So what is scale factor? Now scale factor is actually the length. Scale factor is actually that is the unit length, right, that you use to indicate some unit amount of the, actually the value of that couple is 0.04 my, right? So that value you can equate with this one, and you can find what is the mass my, right? So the mass my you can find, right? Okay, so now my can be very careful about the units, right? So the value for mass my can be calculated, right? Now it is done, right? So now here, now just focus this now focus the force polygon, right? Now initially we were not in a position to sketch the force polygon because there were two unknown things, right? So now one is known. Now you know what is my, so multiply that my by 0.1, then you can know this one, right? So now there is something that you have to do, right? So now you know that we have completed the remaining couple by extending this point D dash up to the starting point, right? So now the fact is that now look at this line, right? So make a parallel line to this one that passes through the center over here, right? Shall I tell that again? So sketch a parallel line to D dash or dash that passes through the center of the angular position diagram, right? See, like that. So if you make a parallel line like that, right, so then that line can be sketched like this, right? Not only like that, that line can actually be sketched from the other side also. That means like something that is going like this, right? Okay, see, parallel line, right? Whether like no there are two forms. Now carefully take it into your mind, right? Now in the line where you make a parallel line to this one, that can either go, carefully focus, see, that can either go from here to here and as well as from here to here, right? But now be very careful now when considering the angular position diagram, right? Now we know that imbalance is caused due to the centrifugal force, right? So now what is centrifugal force? Centrifugal force is a force that is actually directed away from the center, right? That is actually directed away from the center. See, focus, away, the term away. So that means it must get sketched by away, right? Okay, so now my is completed, right? So that is the way, that is how you should think, right? That is the first thing that you have to do after completing the couple polygon, right? So make a line that is parallel to this length that passes through the center towards here, right, such that it is directed away from the center, right? Because that part we are going to use in order to complete the force polygon. Agree? Okay, so now let's go for the force polygon, right? So look at the force. So what is the first value that you can sketch? Go for this one. The first centrifugal force, because of the 200 kilogram mass, that you can sketch 16 positive, right? It is positive 16, so it must get sketched by positive 16. See, it is directed away from the center, so 16 positive. See, so look at this mass, I see 16, that is directed away from the center, right? Okay, so this 16 is done. Then what is the next one? Next one is this one. Still you cannot find, but you can find this one, B21. So B is here, so centrifugal force is directed away from the center, right? So it is going like that, see, away from the center. See, AB 21 units, see, right, 21 units. Then what is the next thing? 24 units. See, C is here, right? So after reaching this point, now you can complete BC. See, 24 units. See, BC 24 units, right? So it doesn't matter. Before that we can compute this centrifugal force because of the mass 200 kilogram over here. See 16, right? Okay, so now after computing this 24, right, after computing BC, now you can sketch this 16 down. See, so this is the mass over here. Centrifugal force is directed away from the center. Now you can sketch this 16. See 16. See 16. So now when sketching the force polygon, that's a scenario, right? Now see, the angle is always measured with respect to the reference x-axis on the right hand side, right? So we have completed A, B, B, C, C, D, right? And now what is next? Now next is, okay, now you can sketch this one, right? What is this? The one that we have already evaluated from the couple polygon, see OY, because now you know the value for OY and you know the position. Now see, this is the most important thing, right? So now you know the position for this mass My. See, you know the position for the mass My. See, it is acting like that. See, going away from the center. See, now see this DE represents the centrifugal force because of the mass My. See, now it is directed away from the center. Just focus away from the center. See, away, right? See, it is going away from the center. See, DE, right? Okay, so now it is done. So we have completed all the forces up here. So now we know that the system is statically balanced, right? So now this force polygon must get closed, right? So just close means anyhow the last point over here must get connected, right? Must again get connected to the starting origin over here in order for the balance, right? So this line should be, now here we have stopped the previous sketching at the point E. Anyhow this point E must get connected to the origin point like that. Okay, see 0.1 times mx, see, because the force is 0.1 times mx, right? See, it is done. So now the force polygon is also, right, completed, right? So this is how it looks after completing. Okay, right. So now we have completed the force polygon vector, right? Because now we know that in order to attain the static equilibrium, right, so definitely this force polygon must get enclosed, right? That means this force polygon must get closed, right? So the last centrifugal force vector that we have sketched is DE, that indicates the centrifugal force 0.1 times My, right? So that the value of this mass My also we have already calculated, right? So now the last point that we have stopped is E, right? So now you know that we have to connect this point E. See that you can see over there. So we have to connect this point E back to the starting point in order to close this polygon, right? So that will indicate the centrifugal force because of the mass mx that is kept at the reference plane x, right? And also we know the value of that centrifugal force, that is 0.1 times mx, right? See, so now our polygon is, now our force polygon is closed, right? So now force polygon is the one that includes or that indicates all the centrifugal forces, right? Okay, right. So now you know that we have sketched this force polygon according to a scale, right? So now the next thing that you have to do is carefully measure this length EO, right? Carefully measure the length EO, right? Because you have sketched this according to a scale, right? So then multiply that from the scale factor, right? Then you will get the actual value for the centrifugal force that is given by, that is given with the units kg meters, right? Kilogram meters, right? So then from that you can find what is the value of the mass mx, right, in kilograms, right? So if you carefully do the calculations, the value for that you will approximately the value for the mass mx that you will get as 355 kilograms, right? So now the next thing that you have to focus is this direction, right? So now just carefully focus the direction E naught, right? E0 or E naught, right? So now see, just if you carefully focus the direction of this vector, you will see that it is directed from E towards O, right? Then only it will get balanced, right? So now, so like that. Okay, so now the next thing that you have to do is, now you have to not only the force polygon, right? So in order to have a better understanding about the structure of the system, right, you must be able to complete the angular portion diagram also, right? So now just sketch a parallel line which is parallel to this line that passes through the center O of the head. So now when considering this centrifugal force vector E naught, right, that actually represents the centrifugal force because of the mass mx, right? The next most important thing is to sketch the or complete the angular position diagram also, right? Because like we have to complete the angular position diagram also in order to have a better understanding about the structure of the masses, right? So how the masses are distributed, right? Okay, so now the next thing is to complete the angular position diagram, right? So now you know that when sketching the angular position diagram, the last part that we have to complete is the angular position of the mass mx, right? Okay, so now for that we need one data from the first polygon, right? So now just carefully focus now in the first polygon, right? This vector E naught, right, indicates the centrifugal force vector because of the mass mx, right? So now carefully see, now it is sketched in such a way that it is directed from E towards O, right? Okay, so now like that, when you are going to project that idea into the angular position diagram, right, it should get projected from the center O towards that outward direction as in the first polygon, right? Now carefully focus, right? It is directed from E to O, right? So that same concept must get applied over here in order to complete the angular position diagram, right? So now when projecting this vector E naught, right, to the angular position diagram, right, such that we are going to sketch a parallel line that is actually parallel to this vector E naught that passes through the center O, right? So now actually initially we are going to sketch a complete line, right, that should pass through the center, right? So now our doubt is whether the correct position is from O towards here or whether it is from O towards here, right? So now we know that as according to the concept of centrifugal force, right, that centrifugal force must get directed from the center, right, to outside, right? Centrifugal means from the center to outside, right? So if you're going to consider like in that parallel line, right, so in this parallel line, so if you're going to consider this section, right, and then like just look at the direction over here, right? From the first polygon, just focus direction over here. So now it is directed from E to O, right? So that direction, if you're going to think in this perspective, right? So that direction, if you're going to think in this perspective, it is directed from here towards center, right? So then that cannot be considered as a centrifugal force, right? So as it is centrifugal, that force must get directed from the center to outside, right? So this is the most appropriate direction for that, right? So that means this like the line segment that you are going to sketch from this O to here, right, as it is pointed by my finger, so that is the correct direction, right? Okay, so then what is the angular position of the mass mx, right? So now we know the correct vector is this one, right? So this is the correct representation, right? So the angle we generally measure from the right hand side horizontal, right? So if we measure the angle up to here, right, starting from the right hand side horizontal, so we have to measure this angle, right? So the value of that angle will be 215, right? So 215 is the angle that indicates the angular position of the mass mx in the angular position diagram.